Just finished the first presentation. The second one will be delivered by Vladimir Alekseichenko, who for a day works in General Electric, but he also runs this podcast, biznesmysli. And I just had the information from the camera gentleman. If you could start on the left, much better light here for the presentation. Okay, I'm giving the microphone to Vladimir now. And to pilot.
Thank you. Hi, I'm Vladimir. Today I want to talk a bit more on controversial talk, how advanced machine learning can predict more accurate, and what does it mean for us in practical, and how to manage this risk. And let's start from disclaimer. I never worked in bank. Kind of neutral news, I work for a company who work for a bank, but this actually doesn't matter. What does really matter, I'm a machine learning engineer, and I know this is three good news. One is, first of all, I don't have a lot of theory about finances. That means that I don't know that something is impossible, and I'm still trying. Second news, machine learning itself really. Second news, I don't have any NDA, and I can tell everything what I can because I don't have any limited. And last news. Right now, there are several examples when people with machine learning background deliver a better result without depth domain knowledge. And this is what I want to show you for start. Example from Google. So Google has one of the biggest data center, and they really optimize a lot about everything what they can figure out. And now we have machine learning people with machine learning background who really don't know a lot about this domain, but they know a lot about machine learning. And when they apply their model, you can see how what the result they achieve. They reduce about 40% energy savings. Next example about PayPal. It's more related for today. And they use deep learning, and in this way they detect better fraud. So the average industry fraud detection is about 1.3032, and they have 1% less. And in this way they save 2+ billions. And third example related with medicine from Stanford. So here we have doctors. They really don't know a lot about medicine, but they know about machine learning. And what they achieve, they model predict better, they exceed average cardiologist performance. Okay, so this is what I want to show you, that right now if you know machine learning and you have a little domain knowledge, you can predict better than expert. Let's go ahead. Let's talk about capability. And let me put analogy. So we have two vehicles, car and plane. Now, if we talk about capability in terms of speed, car is slower than plane, and this is kind of obvious. But on the other hand, plane has some limitation. For example, we need to have airport. We need to have some regulation and so on. And now if you check in terms of machine learning, you can have linear model, and this is the model which has some capability, and you have, let's say, XGBoost, it's special implementation of gradient boosting, and this model is much more advanced. Let's come back. What's the problem with linear model? Because this is linear, that means if we try use, and life is not linear. And for example, if we try predict for this woman, she just married, that yesterday she was single, today she married, that means in the end of month, she will have a lot of months, like 30 or something. So this is about linear regression. This is linear, right? Life is much more complicated. And here is example what we have. So here we have capability, and on other axis we have interpretability. So linear model, low capability, but actually, I'm sorry. But let's say this is good interpretability, this is bad interpretability, right?
Inverted.
Yeah. Linear model has low capability, but really good in terms of interpretability. But deep learning boosting, very good enough in terms of accuracy, but really bad in terms of interpretability. And now the question is, what does it mean for us? Why is this problem? So we have black box, right? But on the other hand, from business point of view, should business care about this? Because if you make money and you have black box, probably it's not a big deal. If the problem is if you lost your money and you cannot manage your risk. And another problem can be law, right? You have some regulation and you cannot use black box. And so we have a problem, we have some solution, which is better than linear. The question is how to manage this together. And there is idea, actually several, from DeepMind. They try to solve in some way from other project. Here is NVIDIA. Next one, when deep learning try to explain why this model works. For example, what sport is this? This is baseball. Why? Because this man, this player holding a bat, right? And in this way, network try to explain why they decided in this way, not in other. Next example. By the way, who is it? What you can say? So this is, so if you have, let's say, deep learning model, this model predicts three things: electric guitar, acoustic guitar, and Labrador. And our question is why? And model try to explain. So electric guitar because this part, acoustic guitar because that part, and Labrador because this. And this is kind of makes sense because it looks like you have some features and it's more or less sensible. But next example, husky or wolf. And she said, this is wolf, and we asked why, and she said because snow. And this doesn't make sense, right? Because snow and wolf, it's kind of related, but this is not a good feature. And in this way we can say that our model detects something, but this is useless, right? And here is a use case how we can manage black box. This is about churn prediction, but it's kind of similar about credit score. We have some features and we have some values. And now, if we check, you can see different color. Red means big impact, blue means big impact in other way. And now you have, for example, profile, and this profile has different value. You can check switch from this to that, and in this way you can see how model will react. So in other way, if law required from us to explain why our deep learning works, we can show this profile and we can explain because this user has this and these features, this model works in this way. And finally, for today, so if you want to get more accurate model, we want to use more advanced model. More advanced model means black box. But black box, we can try to manage. This is not really simple, but right now there are a lot of initiatives, especially from big companies like Google, NVIDIA, DeepMind, who spend a lot of attention here. And just to say about me one more thing. Here is technical implementation, because right now I'm talking more about that exists, but don't show how to achieve. And if you or your team want to achieve on technical level those things, I can show you and can teach how it works. That's all from my side. Thank you.